Wow, it doesn't even fit on the bench. But ain't she a beauty? This is a Pioneer SX-1250, and I may have done a video on one of these already. I know I've done a series on the 1980. I've done a couple of different 1050s. I've worked on 1250s and 1080s and all that, but I just don't know. Again, with all the videos I've done in the past, I can't remember them all. But this is definitely one of my favorite receivers. The 1050, the 1250, and the 1980 are my favorites. I mean, I have to admit. The 1080 and the 1280 I also like, but the transistors are harder to get. They're not quite built like a tank like these are, although they are very well built. Slightly better specs, but these just have a special place in my heart. So this one belongs to a friend of mine who purchased it brand new when it first came out. And the audio store that sold these, I remember it well, long gone out of business many years ago. And he's had this thing its whole life. He used it for quite a while, and then eventually, you know, trends change, times change, kids grow up, you grow up, all these things, and it finds its way onto a shelf in storage somewhere, and there it sits for many years. And he decided to take it back out, and I think he wants to use it again. So what we're going to do is, it just needs a general service done to it. I'm not going to do a full restoration. We may replace some capacitors in places that it would make sense, needing a general cleaning, needing all the controls done. Of course, the faceplate's going to need cleaned up, and we're going to have to touch up the alignment, you know, the bias and offset and all that stuff. I'm sure the tuner will be perfect, but we'll go over it just in case and make sure. But this thing has been well taken care of, and I don't see any reason why it's not going to be in excellent condition. So if you're interested, that's what we'll be doing on this video. So let's get started. Okay, this was working perfectly when it went on the shelf many years ago. So I have speakers and a sound source connected. I'll have some music queued up. Turn on. Protect is in, so that's good. Let's see. Volume is scratchy. Well, that doesn't surprise me. Okay. Very scratchy. So I think we're going to need to clean some controls, but other than that, it sounds like it works. So, all right, let's take it apart and look and see what's inside. Well, I think I have the whole thing in shot. Boy, isn't this thing a beauty. I just love these things. So you can see the two amplifier modules on either end, your power supplies, your filter caps. Look how huge those are. 80 volt at 22,000 microfarad each. Big toroidal transformer, really good high current supply. Massive heat sinks. Totally enclosed tuner. The tuners on these are fantastic. They really good tuner for what they are, especially for the time in which they were made. Just, I don't know. I love these. Can you tell? So what we're going to do is we're going to go through and clean everything. Again, we may replace some capacitors that that might make sense to replace, and then we will go through and check the alignment. But everything looks good on this side. Obviously, we're going to have to clean the controls and clean the faceplate, so let's get that off. I'm going to remove that, and you can see we have some set screws here to remove from these two. The rest of them just kind of pull off, and we'll get this faceplate out and get it put away in a safe place. And while we service this, we'll just leave that off because we don't want anything to get scratched or damaged. Okay, just brush some of this dust off of here. Make it easier to work on. I'm one of those people, I just like, going to be working on something like this, I like to get the dirt out so it's not all over everything and doesn't get into things while you're working. Just makes it easier to work on. You're going to clean it anyway if you're doing a service on it, so you might as well clean as you go. Okay, a word of warning anytime you go to service one of these monster receivers like this. They are very heavy, very big, and very awkward to move around. And as such, you have to be really careful when you're moving them. Take your time. Always make sure that they're not going to fall, things like that. Again, this isn't a race. If you don't have the proper time to work on it, step away from it, because they're not making these anymore. And when they're gone, they're gone. Like I said, these are just among my favorites. I do own and have owned several, like the SX-1050s, and I have 850, 750, 450. Yeah, the 50 series, these are pretty much my favorite. I know that's a debate for everyone. You know, some people prefer more modern gear. Some people prefer Sansui or Marantz or Macintosh or many other different really great pieces of audio equipment from this era. They're all good. There's no doubt they're all good. I think we each individually get our own opinion of them based on our experience with them, based on the designs that we like or don't like, or little quirks. Everything out there has differences, little differences in the design, and everything's got its pros and cons and things you could improve on or whatever, but wow, look at that. So lots of little dust bunnies. I'll go ahead and I'll vacuum that out and clean it, but you can see this is a receiver that's never been touched, never been serviced. I don't even know if it's ever been opened before. It's all original, and I'm going to keep most of it that way, because I really don't think at the end of the day a lot of stuff is going to need to be done to this other than cleaning the controls, checking the alignment, and again, a few of those orange capacitors that they use in these, they notoriously will go leaky, and they won't perform as well, so they will need to be replaced. So let me get some of this dust vacuumed out of here. You can see the little dust bunnies. We'll get rid of that, and wow, this thing's in nice shape. Okay, just to kind of show you some of the attention to detail that is done on some of these classic pieces of audio gear. This gray device here, this is a big ceramic resistor, and it's only about a couple of ohms, maybe 1 or 2 ohms. And it's very large. It can handle very high surge currents. And this is part of that inrush current limiter, or soft start circuit that we call in here. And what this does is this is actually in line with the power transformer. And when you first turn the amplifier on, the inrush current to these capacitors is in the hundreds of amps. It literally could pop the breaker in your mains, in your breaker box, because of that huge inrush of current. And it's only for a split second. It really isn't for very long. So what this does is this absorbs and limits some of that current. And once the capacitors get up to a certain charge, there's a little circuit that will monitor that. It's actually the coil of the relay itself. And when the relay pulls in, and that's this relay back here, and I'll show it to you, this relay right here, it will come in and it will short out that resistor right there and allow full power to the amplifier. And what that does, again, is that soft starts those capacitors so that they don't get, they don't charge all at once and can blow all the fuses in the breakers. And one of the things that Pioneer did on this is, and this is not an uncommon thing to do in these old monster receivers. You just had to do it or you'd be blowing breakers. But if you notice here, there's this wire tied around here. And there's this little device here. And this is actually a thermal fuse. And it's attached to this ceramic resistor. And if this thing does not, like if the relay does not short this out, say the relay fails, and the amplifier is running through this resistor will get very hot and it can actually burn up. So what this will do is this little fuse here will open up and open the circuit. It's a pretty cool little, just attention to detail, like I said. So this is the big power supply down here on the bottom, and then all of the regulated supplies are on the top. These are all unregulated. So you can see these just a couple capacitors, and you have your bridge rectifiers and everything underneath here connecting to all of this, and then the output going to your, and each channel has its own capacitor bank. So you have a plus and minus DC rail for the right channel and a plus and minus DC rail for the left channel, and each one has its own set of filter capacitors. They double up on the wires to give you more current capability. They really went all out on this. This was until the SX-1980 came out. This and the SX-1080 that came out after it were the two most powerful receivers that Pioneer had ever built. This is rated at 160 watts per channel. And, with the advent of these Class D amplifiers that put out thousands of watts and all that stuff, prior to that, this was it, And the sound that comes out of something like this is unlike anything else. I mean, they have so much just dynamic power and so fast, that they can deliver, on demand. Just a great setup. So what we're going to do, normally I would start at the power supply and the power amplifier and kind of work my way back. But really most of this is going to be pretty good. We're going to leave it alone. We'll do some testing in the end to verify that we don't need to replace anything here. And if it all passed the test, we're going to leave it alone. All we are going to do is we're going to take these two, the tone control and switch modules out. We're going to remove them. And then we're going to clean all the controls very carefully and thoroughly. All right, and I'm going to probably do it a little bit differently than some folks that you see, simply because I have the tools to do so, and also because I want this amplifier to be absolutely perfect. I want it to last for many more years to come, and I want people in future generations to be able to really hear what these sounded like. Okay, to get this first module out, there's really only a few screws that have to come out. Now what I did was I did take the socket and I just cracked these couple of nuts loose here so they're finger tight, but they don't need to be out quite yet. It's just easier to do it while it's all attached. Then you remove 3 screws. There's this one, there's one down here, there's another one up here, like so. And this should be about ready to come out. Just like that. And we're just going to be very careful with our wiring. Rotate this around. And this is not a very good candidate for my Lazy Susan because it's just too big and heavy and bulky and it'll tip over. So you can see right here, and again, I don't see any signs. Now there is some, let's see, let's zoom in a little bit. You can see here, I don't know if the camera is focusing or not, but you can see there is some of that glue on there, and it does look like it is starting to harden, so I may replace these capacitors here just to get rid of the corrosive glue. These other ones, these yellow ones, these are low noise capacitors. As long as they're still good, I'll leave them alone. Again, we'll do some testing, but maybe we will replace them. I don't know. We'll have to take a look at them. And most importantly, we're going to clean all these controls. That's a must on these. So remember I said I cracked these loose, and now you know why. So I'll just, now that they're finger tight, I'll take them off. Now there's a whole bunch of screws that have to come out, which are along here. All the switches have their own mounting screws, and then this plate will come off. So let me take those out. Okay, screws are out, and this plate comes right off just like this. And don't put it on backwards when you put it back on, because I always tend to do that. I don't know why. There it is. And now we can get to our controls now. Now again, you can use a bent straw and kind of work your way in there, but I am going to take these controls apart and clean them properly. The switches, I'm not going to have to take them apart because there's plenty of access points to get the spray in there and clean it. But my goal, and this is a personal preference, this has no, I'm not telling you to do it. I absolutely can't stand when these boards get embalmed from people spraying all their spray all over it. And you know, a lot of people misunderstood what I said in my control cleaning video where I kind of made some fun of some folks with the they kind of get happy with the deoxit stuff. That stuff is designed to leave a residue in there. It's a protectant. It protects switches. It protects metal contacts, but also it doesn't evaporate. And when you spray it and it runs all over the board, it will soak into the fiber of the board and it will make it gross. And then it will collect those dust bunnies you saw. Imagine soaking those with deoxit and having them smear all over the board. It's gross and I don't like it, so I don't do it. I personally rather just take my time and clean this and not leave any kind of garbage on the board after I'm done. So that's why I do that. Okay, hopefully you can all see from this angle. Now I'm going to remove this volume control right here. And if you really need to have the proper tools to do it, you'll see that there's 8 pins on here because this has a loudness tap for loudness contour. And 2 of the tabs are bent over. You have to be extremely careful taking those out or you will lift the traces right off this board and damage it. And the idea is you don't want to leave any trace that you were ever in here other than any components you have replaced. So you have to be really careful. So these first 2 I'm going to remove with solder wick like this. And the reason being is I have to be able to get under these little tabs, and a desoldering station does not do a very good job of that. Okay, so see how clean that one got? Now we're going to do the other one. Let's see here. And the other ones we can get with the desoldering gun, but these ones we have to take this way. And there's quite a bit of solder on some of these, so you gotta use up a little bit of braid. But again, this control is very hard to get if you ever need to replace it. So you want to be very careful with it and very careful with the circuit board, or you might be out of luck. So we're going to take that out, and then we're going to straighten out these bent pins. Okay, and you have to use a temperature controlled soldering iron, and don't get it too terribly hot, but hot enough to melt it though. But you don't want to lift that trace because you're going to be on there for a little while with that braid. But you can see when you get that off, the tabs lift right off, no problem. If it shows any resistance at all, stop. Like, see that one? It's still showing some resistance. So we're going to reflow it a little bit. And we're going to start over again. Okay? It's just what you have to do to get it right. Now, some of you who do this for a living or who do this, have done this for a long time for a hobby, You have your own way of doing it, and if it works for you, do it. You know, I get it. But this is what works for me. Okay, there it is. Now we should be able to lift this one up. Yep, there it is. And the trace is in perfect condition. And then we don't have to worry about damaging it. Now the other ones will come out very easily. Okay, and there it is. And then it just pops right out. And there it is. And then what I will do is I will get a little bit of alcohol on a swab, and I will clean off any of the flux or anything like that. And there you go. So now we got this control out, and we're going to do the same for this one up here and get it out. Okay, and there are our controls. And I will try to stay in camera while I do this. So let's clean this one first. This will be the easy one. Okay. We're going to just... And this is just that QD quick drying, no residue stuff that I'm using. And I really like it because it won't leave any kind of oily mess behind. And you can really spray it to get all the gunk. This is really what you're going to use to get any kind of grime or grease or any kind of stuff that has gotten collected inside the potentiometer over the years. And the nice thing is once you use it to wash it out and get everything clean, it evaporates and it doesn't leave any kind of residue behind for that to happen once again. So there you go. Okay, and when it's thoroughly cleaned and dried, we're just going to take a drop of the fader lube, and I'm going to move the wiper around here. And I'm just going to put a drop on each corner here. One there, one there, one there, and one there. Just a drop. Then I'm going to just let gravity do its thing and work its way down through there. I'm trying not to get anything in here because that damping grease is inside there, and we don't want to wash that out or this will get all loose and loosey-goosey. We don't want that. Okay. And then we just give it a good wipe down again, get rid of any kind of dust or residue, and we should be good to go. Okay, this one's going to be a little trickier because it has to be disassembled in order to clean it. And so the only way to do that is to clean these off really well so this little mylar piece can slide off, or a little plastic piece. And then we have to disassemble the sections in it. Okay, now that this is cleaned and we have this off, we have 2 screws, one in each corner. And we're just going to remove that. And then remove the screws, and you want to kind of hold everything together because this will come right apart now that you do this. Okay, now the first thing we're going to do is we're going to try to see if we can get in this and clean it without taking it apart. There's a label back here, And there's two different layouts of these. The first one, there'll be a little clip, a C-clip that's in the front that you can take off, and then you can push this through this way and it comes apart. On this one, the clip is in the back and there's a hole in here, and in order to do that you have to cut this label off, and I really don't want to do that. I want to deface this thing. So what we're going to do is, this does have some spring tension on it holding it together this way. So what you can do is you can just open this a slight bit. You can see just a tiny amount, and we can get some cleaner in there, and we're going to try to clean it this way first before we and if I still can't get the noise to go away, then we will have to take it apart. There's no other way we'll be able to get in there and do it. So okay, so that's the back section. Just keep it on, and we're just going to hold it together like that. Then we're going to go, and I'm just going to shoot a little bit in this front section here, just a little. And I'm not going to get it up in the front here, and let it dry, and then I'm going to put these screws back in like this to hold it together. And I'm going to flip this over, and let me get a meter connected. Okay, I hope I have this all in frame now. So again, this is a stepped attenuator. This is not a actual potentiometer like you would think, and they're not put together like you would think either. There's actually little wafers in there, and they have little resistor sections and a wiper that goes around and picks off those resistors, and they're set at it's a logarithmic taper, so each resistance level is logarithmically higher than the other to mimic the hearing of the human ear. And this tap here on the end, on this side, this is your loudness contour tap, and it's tapped in the center of the resistor network. So you'll see what I'm talking about. So from this here to here and here to here, of course right and left channel, this is the pot from end to end. So this will be 50K because this is a 50K pot. So when we measure that, there's your 50K. It's just under 50. And you'll see that these two sections match very, very closely. They're identical in resistance. Now, if we go from this end to this tap, okay, you can see as I go up, the resistance goes up. So this is the top end of the pot. So we're actually reading it backwards right now. Okay, and you can see each click is a very well defined resistance change. Okay, and it's not going to read right from this end because this is not the ground end. The ground end is over here. So and you can see as I turn it counterclockwise, the resistance is getting lower on that end. All right. Now if I go to this end, and this is where it's really going to be important, as I go up, I should start seeing it move ever so slightly, and see it's just making little tiny changes in resistance. See that? And then as you get louder in the volume, you can see it will make larger and larger differences. See that? Okay, and there's the end. So if I go from here, one click, that jumps it about 1.8K. So I should be 1.8K on this one as well, if they're matching. And there it is, right on. If I go to the next click, we're just about 6.5K. So if I move it to here, 6.5K again. If I go one more click, just over 11K. So go here, just over 11K. So you can see how perfectly matched these two sections are, and it's because there's not a carbon track that the wiper's going around. There's actual little sections of resistor on there on the little circuit board. Again, if this were the type that had this clip on the front, I would take it apart so you could see it, but I don't want to ruin this label. If you needed to, now if I was unable to clean this and those contacts would be jumpy, then I would have to take it apart, and in this case I would have to cut this label, and the little clip to take it apart is back there. But luckily that cleaning was just all it took to get it to work once again, and it's not going to be all scratchy anymore. So right there is just over 20K, and again just over 20K. Why am I comparing the two sides, you ask? Well, if these track exactly the same, that means that both your right and left channel are going to track exactly the same as you turn the volume up and down, and that's really important. When you use an analog potentiometer with a carbon track, sometimes the two elements are slightly different, so the the volume will go up at different rates on the left and right channel, and you have to mess around with the balance control to get it to balance. But with these, that's not the case. You have solid resistances, and that's the advantage of a stepped attenuator. Now in some of these pots, these carbon trace pots, they actually have a little adjustment for one of the wipers where you can actually make the one wiper line up with the other one. But these cheaper pots like this don't have that. This is the way to go though, if you can do it. Now the only downside of this is, the difference between this volume and this volume can be quite audible, and you may want something in between there. And that is why there is a muting, a minus 20 dB muting switch on there, and it actually changes the whole range of this pot once again. We'll look at that later, but long story short, this is now clean and is tracking perfectly. Now for these metal switch contacts, we're going to use some deoxit red, and this is perfect for that. And this will just clean it a little bit and leave just enough product in there to lubricate the little contacts in there. And what I'm going to do before I do anything else is I'm going to take this paper towel and put it in here to catch any kind of overspray, because again, I don't want this board getting all soaked up with deoxit. We're just going to put this couple little spots in here, and then we're going to work the switch back and forth a whole bunch of times. Like that. Then I'm just going to use this paper towel, wipe this up a little bit, and that cleans the metal off, any kind of corrosion on the outside case, and that makes it look nice. And then we're going to go down to the next one and do the same thing. Okay, one more maintenance thing I'm going to do on this board here is there's two transistors, and they are both 2SA725s. They're PNP transistors, and these are notorious for shot noise, and I've seen this happen a lot of times on Pioneer gear with these transistors. What will happen is you'll be listening to it, and then you'll just hear this kind of snap, crackle, and pop sound, and sometimes even the whole channel will just go out, and then it'll come back on, and it'll play for a while, and it'll drive you crazy. And it's these 2SA725s. I don't know why they don't work so well, but they just aren't that, they just fail a lot. You see these a lot in, for instance, the SA7500, the SA8500, those things, they're all always in these kind of positions in the tone control boards and so forth, and it'll drive you crazy. So I always replace these as just a maintenance thing. And again, the 2SA763 sometimes they'll use in other models of Pioneer gear, and those ones don't seem to ever do that. But these 2SA725s, known for it. Now, you can use a KSA992, but you have to be aware that the pin out is different. So if the pins on the board, and you can see on this one, if I can zoom in far enough without going out of focus, you can see the pins on this board are in a triangular shape. So you can kind of contort the, turn the transistor in any orientation you need to fit. If the pins are 3 in a row like that, straight across, it's hard because you can't really bend one, you got to swap the center pin with one of the end pins to make it match this one. So that may not be a good fit. But on all the Pioneer gear, they always put their transistors in a triangle shape. So you can actually just change the orientation of the transistor and you'll be good. Because this one, I believe, is base collector emitter, and this one is emitter collector base or something like that. Let's check it. I think this one is ECB. This is the KSA992. And you can see it's ECB, so emitter collector base going across. Back this off. Emitter collector base. And if we stick one of these in there and look at it, you'll see that it's base collector emitter. See that? So you just have to remember that when you put these in. And as you can see, the transistor will test just fine. It's not, the transistor element itself really doesn't fail. I think it has to do with the bonding wires, where these leads actually bond onto the actual die of the transistor inside. That's what seems to fail on them for whatever reason. And you can see they try to fix that by putting like a black paint coating on the leads. You see that? But it doesn't help. They still fail. So I'm going to get these transistors in there, and then I'll show you when I'm done. Okay, the new transistors are fitted in. You can see them in there. Good to go. Okay, the board is done. All the controls are clean. I did remove 4 capacitors because they had that, that glue on them, and some of the glue had gotten onto some of the leads of some of the components, so I cleaned it. While they were out, I just replaced them. I could have put them back there in absolutely perfect condition, but I figured I'll just put new ones in because they don't cost that much. They're so cheap. So that's it. Okay, everything in these amplifiers is just really well shielded. You can see this. The line, stage, and tone control section is very well shielded. And that's why this makes this such a quiet amplifier. And you can see this one is loaded with those orange capacitors. And in my experience, these ones, especially the ones with like the epoxy on the bottom instead of the rubber on the bottom, they tend to get leaky with time. So these ones will need to be replaced. And these are caps that just during during a servicing, I would replace those ones, and that's what I'm going to do. These controls are not potentiometers. These are switches, and as such, they have the openings in them, so they're easy to get to, so I won't have to remove them. And we'll just spray some deoxit in those ones using the same kind of process we did on these switches, and we'll just go ahead and clean that up. Now, just like the other board, there's a couple of problem child transistors on this too. And these are those 2SC1312s. And the same thing, they'll have dropout and so forth. And I think, again, they have problems with how the leads connect to the bonding wires and to the die inside the transistor. So these will go bad as well. And I think there's 4 of those. I think all 4 of these transistors on here are 2SC1312s, so we'll have to replace those 4. And for those, we are going to use a KSA 1845. And those work great. Again, they'll be a perfect replacement, although the pinout, once again, might be a little different. We'll have to check that. So let's get the maintenance done on here. And again, these orange caps, I'm going to replace those because I've noticed that those tend to get leaky, and these are direct audio path capacitors. You really don't want those to drift at all, or to have any leakage or any high ESR or anything like that. So we're going to replace them. All right, I'm getting ready to replace the capacitors in the tone control board, and I get this comment an awful lot, and I thought I would address it. A lot of people get concerned about the physical size of capacitors, thinking that possibly a larger diameter capacitor is better than a smaller diameter, all other things being equal, meaning the specs of the capacitor, the voltage and the capacitance and so forth. But really that is not true. The reason caps can be different sizes is because they have different lead spacing and so forth to accommodate the different places they're going to be installed. So, case in point, these are 100 microfarad at 16 volts, and we did tests on this in a previous video, and you saw how good these Nichicon KT series performed. By the way, they don't make these anymore, they're being discontinued. But if you look at these 100 microfarad at 10 volt capacitors, which are the Nichicon Fine Golds, they're actually physically larger, even though this is a 16 volt cap and this is a 10 volt cap. And a lot of people will say, well, that's because this is a better quality capacitor. And that's really not the truth. You can actually order this same cap in this case style. It's just that I had this one in stock. This is what I had in inventory, so we're going to use it. But if it's an FG series, for instance, it does not matter what size case they put this in. It could be in a case that's this big, but if it is 100 microfarads at 10 volts and it's an FG series, it will perform exactly the same as all the other ones. So really the sizing of the capacitor doesn't matter. People get into, well, this one, it has inductance or whatever. If they are the same spec, if it is an FG series and it is this capacitance and this voltage, it doesn't matter what case they put it in, it will perform the same. The only difference is they change the different sizes to fit the different boards. That's really it. But if you look at the spec sheet, they all have exactly the same specifications in every way, shape, and form. So I hope that answers that. You know, I kind of thought those same things myself, but really it's not about how a capacitor looks shape-wise. It is literally all about the specifications, and no matter what case it's in, if it's spec'd out a certain way, that is how it will perform. Okay, let's get these installed. All right, all the service has been done on the line and tone control board. And now for the fun part, which is these little switch modules up here. If ever there was something that you need to service, it's these. And these are also some of the most miserable ones to do, because you have to kind of take everything out and watch all these wires. And once you do get to these long switches, you're going to find that they're not really easy to clean. But it's very necessary, because they often are the causes of a lot of problems in these. So let's take them out and start cleaning them up. Okay, just 2 screws and this board just kind of comes out like that. And to get these out, I've already started this first one. You have these little plastic clips. There's going to be a couple ways you can service these depending on how they're assembled. Some of them are put together and crimped with little metal clips. This receiver has the easier ones. You have these little plastic clips that you can just take a hobby knife and just kind of pry it out very carefully and remove it, just like so. Okay, now that this is off, reposition the camera here a little bit, you're going to take some deoxit, some red deoxit, and just the tiniest little bit is all you need. And we're just going to let it, just put a little shot down in the back here. We don't want to move any of this. And just let it foam down in there a little bit. Okay? That's all you do. You don't want to get anything in there. Now here's the trick. You might think that all you have to do is pop this back in there and it'll work. But what will happen is if you put this, just stick this in here like this and put it together, this button will stick. Now I'm going to try to get the camera as close as I can without actually going out of focus. Right there. And I want to show you something here. I don't know if I can, how well I can get this in focus. But if you look a little bit, there we go. Right inside here, there's a coil spring, and that spring is going this way. It holds the little pin, which is the latch for the switch. And that coil spring will hang down and get caught on this little piece here. So you have to have a very narrow jeweler's screwdriver. I'm going to try to do this around the camera. And what I'm going to do is reach between here. And I'm just going to grab that coil spring and get under it. It's very hard to do. I'm going to hold it up like that. Then I'm going to pop this in. And then that spring falls down on top of it. And if I did it right, this switch will move very smoothly. Just like that. Now, if I didn't get that spring up there, what would happen is this little fiber board here, or whatever you want to call it, Bakelite or whatever it is, it will get stuck on that spring, and it'll put pressure on it, and it'll cause the latch to stick as it's going past. And it makes you think that the switch is defective, but it's not. Okay? Now, once that is working, you're going to go put this back on, like so, and snap that on, and we're in good shape. Now, in the event that this one does not, that it does not have the clip like this, that it has the bent over, some of them have a metal case instead of plastic. What I'll do is I'll get a thing called a pin vise. Let me see if I have a pin vise. So here is a pin vise. It's just a hand drill. It's a little tiny handle with a chuck in it, and you can put a tiny little drill bit in there. And what I'll do is I will very carefully drill a hole in the back part there. Just a tiny hole. And then I'll put the deoxit in there, let it wick down and clean it. And then I don't have to take that apart. These ones with the plastic are a lot easier to do. So I just do it that way. But always remember that little spring. And if you ever have one of these get stuck like that, where it like will stick and it won't come out, the first thing I would look at is that little coil spring that's, you can kind of see it between here and here. And it goes around this way. It's two coils. It makes two turns. And it just compresses like this. And it kind of holds this latch. This little wire here is a latch. Holds that in place. So you want to kind of get in there, pry it up inside this plastic part here so that this will go underneath it, and then you're going to, when you pull this out, it'll drop down and put pressure on this little brown cover here. I hope that explains it so you can understand. So I'm now going to do this one and these ones and get them cleaned up and put them together, and then we'll move on to the next one. Now, in addition to the switches that we have to service on here, this has a couple of 2SC1313s, and just like the 2SC1312s, they are subject to getting shot noise, and they fail. And again, I think it has to do with the little bonding wires that goes from the lead to the actual silicon die in the transistor. Again, the 1313, two SC1312s. All those are very commonly used in this generation of Pioneer gear. And you have to watch because they have that problem. And like I said before, I've changed out quite a few of them. If you go back and look at the video I did on the old married couple, which was an SA-90-100. I did a video on an SA-7500. I have an SA-8500. They've all had the same thing. It's these transistors. So if you're in there for the couple of cents, you know, that these things cost, I would highly recommend replacing them, because it's just good insurance. These KSA 1845s, they just don't go bad. Once you put them in there, that's permanent fix. Okay, I have this top assembly all put back together. These switches over here were cleaned. I have this last one out and it's cleaned up, and now I have to get it back in, and this is really tricky because all these wires are so tight in here, so you have to be very careful. Just like so. And then like that. And then we'll put the screws in, we'll put this back together, and the whole bottom part here is done. Okay, so the next thing we're going to work on here is the power supply and the protect board and all that. And it's two boards. This one up here, you can see the relay, and this one down here. So I've just pulled the 3 or 4 connectors off the bottom of the board, and now we're just going to get a long screwdriver and we're going to remove the board. Okay, I am going to do this entire clip once again from the start, because when I moved the camera mount, the power connector for my microphone preamp disconnected, and the whole time I was talking it was not recording any audio. So let's start this over again. So what we've done is I've removed the this is called the stabilizer board, and all it is the regulated power supply for the receiver. And the main service that's going to be done to this board, because of the condition it's in, is I'm going to replace all the capacitors on it. I'm also going to verify the resistors. We're going to check them, but they look to be okay. Even though this is what I would call a low hour unit and it's a one owner unit, you can still see maybe in the light where this side is a little bit lighter color than this. This actually has been darkened a little bit by all the heat, and there's a lot of activity going on this side of the board. These transistors run relatively warm. There's a lot of heat and there's very little airflow inside this receiver. You can see this board is actually stuffed right in between one of the power amps, and this driver transistor heatsink gets very warm. You're right inside there between the capacitors and this, and there's really not a whole lot of space. There isn't a lot of air holes underneath to allow convection, and you just don't get good air circulation. So these capacitors just kind of sit in there and cook. So the electrolyte in the capacitors dries out and they become less effective and they wear out. This one here has already gotten bulged, and you can see from the heat where the heat shrink, the plastic on it has shrunk away. I don't know if you can see that in there. And so they just need to be replaced. Now, before I start on any service on this is an original factory board that has been untouched and not serviced. And there's a lot of flux that they leave on the board, which is not a big deal, really. People get all uptight about that, but if it's non-corrosive flux, it really doesn't hurt anything. If anything, it kind of protects the board a little bit, so I'll leave it on there. I will put alcohol on here, and it'll kind of reconstitute that flux and kind of respread it and make it shiny and clean again. But what I want to draw your attention to is, if you look real close here, you see these little marks. See this particular one, how there's a ring around it, like a little groove cut, circular groove. There's one here. I don't know if the camera's picking it up. There's one here, there's one here, there's one here. This whole board, just from the heat, the solder joints have started to fail. And what's going to happen is that's going to cause these components to not work properly because they're not connected. That, depending where that is in the circuit, that can cause a lot of problems because some of these transistors can start to dissipate a lot more heat than they normally would under their normal design conditions. And that can cause a lot of problems in the amplifier. Now these ones may not have gone the whole way yet, but you can see they're starting. And yeah, there's a really bad one there. So we're going to go, once we clean this all up and replace the components we're going to replace, I'm going to go through and I'm going to reflow all of these joints with fresh solder and make sure that everything's good. And again, when you say you're just servicing something, one of these receivers, don't think that it's a 10-minute ordeal. It's still a lot of work. It's not as much work as if you did a full-on restoration where you're taking everything down to the chassis and cleaning it and painting whatever it needs and putting it all back together. But it's still a lot of work to replace the components that age and fail and to take care of little things like this. If you don't, something like that can come back to bite you later on. And the last thing you want to do is have one of these things, you know, you do all this work and you send it back to the owner and then it fails because you didn't take it, you know, to where you need to take it to make sure everything's reliable. All right, so let me get started and I'll show you as we do get some progress here. So here's a good example of what I'm talking about. This is a 47 microfarad capacitor. I'm sorry, 22 microfarad at 50 volts. And you can see it's bad. It's very bad. And that is a problem. So here's another 22 at 50. Let's see what this one is. That one's 662 picofarads. That's better. Okay. This one's a 47 at 35. Let's see what this one looks like. That one's 563 picofarads. And this one is another 47 at 35. This one's a little better. It's reading 1663 nanofarads, so it's 1.6 microfarads. So this is what I'm talking about. Every capacitor on this board, if it's not bad, it's going to be bad, and they need to be replaced. Okay, here's another tip that can kind of indicate if something needs to be replaced or not, or should I say something should be replaced. Whenever I work on these things, and of course I'm off camera, I look at the big power transistors and I'll take a screwdriver and I'll just go and check if they're tight. Now this is falling off loose, and what that means is that this transistor may not be that well thermally coupled to this heatsink. Now when I checked these ones, they were relatively tight, meaning that they were making good thermal contact. But this one, since it was not making good thermal contact, the only thing holding it against the heatsink was the paste, the heatsink paste itself. And there's a possibility that this transistor was not properly heat-sunk, I don't know, how do you say it? And as such, this transistor may have been heat stressed and possibly could fail in the future. Now, one thing you can do is just redo the paste and, you know, tighten this down and hope for the best. If it's working, it's probably going to be okay. Or if you want to go the extra mile, once again, you can replace this transistor. Now again, In a full restoration, you wouldn't question any of this. You would just go through, you would replace all the silicon on the board. But we're not doing that. We're only going to replace the things that need to be replaced, or that are a very high probability they will fail if this thing goes back into service and starts getting used on a regular basis. So this one transistor I will probably replace. These ones, since they were tight and they don't seem to have any discoloration from heat, the heat sink doesn't look to be discolored like some of the other ones that I've worked on in the past, I'm going to leave them alone. Okay, this is a 2SD325, and I am going to replace it with a KSC2073, and that should take care of any issues we may have with this. Okay, everybody has their own way of reflowing a board with solder, and my way is I have some of this kind of thin liquid flux, and it's a no clean flux, so it's non-corrosive, and I go over all the joints I want to touch up, and I just put a little drop on there, and it does put a lot of flux on the board doing that. And the reason being is I'm not going to remove the existing crusty solder off of there. I'm going to just add a tiny little bit of this. Now this is flux core solder, but it may not be enough to reconstitute the solder that's on there already, and I don't really want to add so much of this that you have a gigantic blob of solder on each joint there. So this helps that, and this will make everything flow out really well. When we're done, what I'll do is I'll go over the whole thing and clean it with isopropyl alcohol. I'll clean it very thoroughly, and then I'll get a nice coating of that alcohol on there, level the board, and just let it kind of flash off. And what will happen is that the remaining flux that did not get cleaned off, it will be very thin, and it will kind of level out with that alcohol, and as the alcohol flashes away, you'll have this really nice sheen on the board. And that flux kind of helps to protect it a little bit from, believe it or not, from corrosion, because this is a rosin type flux, and it's non-corrosive to the copper and to the solder and so forth. So you'll see as we do it. So let me go through and reflow these, and I'll be right back. Okay, and when we're done, we have a great big old mess just like this. So now we're going to just take some alcohol. I want to use the 99% anhydrous alcohol, which doesn't have a water content. The water actually, in the type of rubbing alcohol you get in the drugstore, it can actually leave like a haze on there and make it look ugly. So you don't want any water, so you want to use the alcohol with no water content. Okay, you definitely want to wear gloves for this process, because this alcohol mixed with flux, that the rosin type flux gets on your skin, and it just kind of stinks. It doesn't smell good. It's really hard to wash off. It has to kind of wear off. So just to avoid that, I wear some gloves. And what I do is I just put a nice coating of this anhydrous alcohol on there. And then, if I can find my brush, you can see how it's already pooling up and starting to melt the flux. And I just go through with a brush and I just clean everything. Just clean the flux that's really crusting up everywhere, and just kind of get it to look good. This is messy. It'll splash around and everything, so put paper towel down. Don't wear clothing that you don't want to get stuff on, all that sort of thing. And again, you're working with chemicals. You're working with lead-based solder and things like that. And, take the proper precautions, okay? You can see I usually, when I'm doing a lot of soldering, I will use a fume extractor. I'm actually in the process of having installing a nice one into my bench I will eventually use. It'll be a little more convenient and take up less space on the bench. And again, when you use a soldering iron, you never get the lead hot enough to vaporize, so you're not really breathing lead when you're soldering. But what you are breathing is the flux fumes and things like that, which definitely can be irritating to your lungs and so forth. And you know, all the medical folks out there can tell you all the precautions and so forth. But you know, use your mind there. Understand that. And if you use anything else to heat solder, like a torch or something, understand that you can cause lead vapors after it gets to a certain temperature. But the temperature that the average soldering iron runs at typically doesn't get hot enough to do that. It will liquefy the solder, but it won't vaporize it. So mostly that smoke you see and smell is the flux and different things like that that are evaporating. And while those aren't great to breathe, especially if you have allergies or so forth, it's not the same as breathing lead, for sure. And like I said, wash your hands really well. Even if you don't wear gloves, like sometimes I don't wear gloves when I solder, you see that. I always wash my hands thoroughly before eating or touching my eye or my face or anything like that. Okay, so now that this is all cleaned off, if it's really bad, you may have to flood it a few times and then kind of let it roll off onto the paper towel. And what we're going to do is we're just going to let this, it's liquefied right now, we're going to let it flash off, and when we're done we should have a pretty nice looking board. And about 45 minutes later, this is what you're left with, and you see how shiny it is. And you should not be able to leave fingerprints or anything on there. It shouldn't be sticky at all. It should just feel kind of like shellac on there. That'll be a nice board. And all of the nasty rings that we have on the solder joints are now gone. Okay, the board is back in, and it's time for a test, because we've done quite a bit between the underneath of the amplifier and this stabilizer board. So let me connect the ground, and let's turn on. We'll look at our negative supply first, and these are supposed to be your plus and minus 65 volts, and we will check them. Now I have 400 watt dim bulb tester on there just in case something decides to short. Okay, that's very good. The bulb brightened and then went totally out. And you can see we're very close to 65 volts, and I have a feeling after this warms up it'll be pretty close to being right on 65 or negative 65. So let's go to the positive, which is back in here someplace, if I recall. Yeah, and see, they're very well balanced. So there's no need to even adjust the potentiometers. They're good. All right, let's play some music, because if you recall, we replaced a whole bunch of components in the audio path, and we cleaned the controls, so we want to make sure we got that taken care of. So let me get some music connected and some speakers, and we'll be right back. Okay, we are on. I still have the dim bulb on, but it's pretty heavy, so we should be able to get some audio out of this, some clean audio, as long as I don't go too loud. Let's turn some volume up, and let's just start in the middle of a song here. I'm hearing some distortion on the one channel. Do you hear that? Of course, that could be because of the dim bulb. Not sure. Well, it definitely plays, and it's definitely loud, and definitely anything that was not nailed down was vibrating. But that being said, the right channel, I heard a little bit of distortion in the background. I heard some, especially with the heavy bass passages. I don't think that was because of the dim bulb. So there is a component, either a capacitor or something, still in there. Remember, we've not touched the amplifiers or anything like that, and we have not cleaned the speaker terminal contacts either for the relay. So we may have to clean the protect relay or replace it. But everything's working, and that's a good thing. And our voltages are good, and there's no hum. Turning up the volume. It is absolutely dead silent. No hiss, no hum, no nothing. So I'm fairly confident that it's not a transistor that's causing the distortion. We still, somewhere in the audio path, have a bad capacitor. Okay, well, that's a good thing. Let's continue on, and we'll do the amplifier section now. Okay, I'm getting a little ahead of myself. I realized that I just said we're going to do the amplifiers, but no, we're going to do this other power/protect board first. Then we'll do the amplifiers. I want to make sure everything around the amplifiers is good before we tackle those. So let me, first thing we're going to look at is this relay, and I'm going to pull it so I can take it apart and very closely inspect it. I say this on a lot of my videos. If the quickest way to damage a speaker protect relay is to turn the volume way up on an amplifier, especially one like this that's very high power, and then turn the amplifier on. Because as soon as this protect relay comes in, you have a whole bunch of voltage and signal on the one set of contacts, and as you close them, you're now connecting a very low impedance load, your 8 ohm load, which the DC resistance of that load, when it first connects, is only about, it's about half of the actual rated impedance. So if, an 8 ohm speaker is going to have only 3 or 4 ohms on it, and that can vary also depending on the speaker. Now you do have a little bit of reactance, but for the most part, it is going to absorb an incredible amount of energy, and that's going to really arc these contacts up. So always a good idea. Turn the volume all the way down on your amplifier before you turn it on. Wait till the protect relay clicks, till you hear the click, then turn your volume up. If you do that, these will last in a very, very long time. Okay, I'm not sure if I'm going to be able to get this on camera or not, but take a look at the contacts on this and you'll see kind of what I'm talking about. These are gold-plated contacts. If you look at it from this angle, the top row is called your normally closed contacts, because normally with no energy on this, they are closed. We don't get too fancy with verbiage in the electronics industry. But you can see now these are the ones that are not used. Okay? They're not connected to anything. As a matter of fact, if you look at the board here, that top row doesn't even have any solder pads on it. Now, the bottom row, however, are your normally open contacts, and they close whenever the relay pulls in. And if you notice something, and I don't know if it's showing up or not, the top row of contacts are still nice and shiny gold, except for this last one here on the end is starting to change color, but see how it's turning black? If you look at the bottom ones, however, they've turned like a black color. They've gotten tarnished. See that one, especially this one right here, and if you look at this one on this side as well, I hope you can see it. Come on, focus. There, see it? And what that is again, from the heat, from this pulling in, when the volume's turned up, they will tarnish. Now, if you do that a lot, and you have the volume way up, what will happen is that, that little arc, when they close, will continue to burn off that real thin plating on there. and it'll cause resistance. Now I would probably guess that these ones don't have very high resistance yet, but they're starting because they're turning that black color. So we may be able to clean this one and reuse it. But if the plating is gone, I will most likely replace it. Now I never use sandpaper or burnishing tools or anything like that on these types of relays because they really weren't made for that. Some of the bigger contactors that have large contacts that are designed for that arcing can be burnished a few times before you replace them because their contacts are the same material the whole way through. These really tiny ones are designed for smaller currents and smaller signals. And if you notice, the contacts are tied together. So you have one pair tied together for the right channel, one pair tied together for the left channel. And what will happen is, just because nothing is perfect, these little springs are ever so slightly different distances apart. So no matter how well they design this, there will always be one of those two contacts that will close before the other. And that's the one that'll take the arc, and that's the one that'll turn the dark color first. And then the other one, when it pulls in, will not get as much current, so it'll usually stay nice. Now there are some relays that are purposely built for that, and those are called bifurcated contacts. And usually what you'll see with those is one will be very large, a heavy contact. The other one will be a small contact with really highly polished gold terminals. And the whole idea of those is the big contact takes the arc, and the small contact kind of shorts out any little residual resistance that the big contact may still have. So we'll check this, and then we'll try to clean it. I'll show you how I do it. And then if it's good, we'll put it back. If not, I think I have a replacement for this, and we can replace it. Okay, I have a very accurate ohm meter that can read down into the milliohms connected to this. And I'm on the first contact, and this was one of the ones that was kind of tarnished looking. So let's take a look and see what type of resistance is on it. Let's see if I can get around here. Let's get this light out of the way so you can see around it. There we go. All right. So when I push the relay in, you can see I have somewhere around 1/2 ohm to 1 ohm. And that is the actual true resistance across those contacts. And you see if I wiggle it a little bit, it changes. Now, in most circumstances, 1/2 ohm to 1 ohm isn't a big deal, but when you're feeding energy into something that is 8 ohms, and under some circumstances, because of reactance, can be way down even towards 1 ohm, you're dividing the voltage between the resistance of those contacts and the source or the load that you're connecting it to. That's a big deal. Let's try a different set of contacts now. The next one's down. Okay, we're down on the next set of contacts. Let's get it on the meter. And when we close it, wow, way worse. Look how bad that one is. Very bad. So that is the cause of our distortion in the speakers. Now, we can try to clean that. Let me go to let's do the last two sets of contacts. Okay, so here's the third set of contacts. Get connected on it. Again, that one's the lowest of all of them so far. So that is why that channel, the other one channel, was not distorting really that much. And here's the last set of contacts. And of course, very, very bad. And remember, those contacts were getting that black stuff to them. Now, if I go to the normally closed contacts that aren't being used, you can see they're less than 0.3 of an ohm. There's about 0.3 of an ohm. Okay, and that's without being cleaned or anything. And if I go to the next ones, and that's a really good set. That's what it should look like. See that? So our relay is bad, and I can clean that tarnish off, but once that really thin gold plating starts to tarnish or to burn off of it, it will just come back as soon as you use it for a little while. You'll be a hero because you fixed this thing, and it'll sound really nice, and 6 months into it, it'll be doing this all over again. So we're just going to replace the relay. Okay, here is a brand new high quality relay. I'm connected to the normally closed contacts. This is actually a better spec'd out relay than this one. It's got rectangular contacts instead of the little round ones, better surface area, higher current rating. And when we look at the resistance, that's what it should look like. 8 milliohms, and that's good. So we're going to replace this. Okay, the new relay is in, and as you can see, I had to widen the holes a little bit so that these tabs can fit through there, because if you remember, these had the pin type, and they actually make this MY4 relay in a pinned type, but they're very hard to find. They're usually not in stock. If you can find them, that's great, because they'll just drop in and replace these, but most of the time you're going to find the plug-in type with these wider pins. So what you need to do is you need to widen those holes so that you can get them to go through the board. Now, if you're not careful, you can do a lot of damage. You just have to be really careful. And especially where the pins are almost to the very edge, you're going to kind of come off of the edge a little bit. And you're just going to have to use a little binding wire, a piece of bus wire, wrap it through the hole there and kind of lay it over there and solder it in, and you'll be good. But what I use is I use a Dremel, or a rotary tool, and I just use these bits here, these little burr bits. These are carbide, or these might be high-speed steel. And you can find ones that are straight, but they're very unstable and they break very easily and snap off. So I use these little pointy ones, and I just use just about the first little bit of it there to just go back and forth. And you have to take your time. You can't get in a hurry. You'll slip and mess things up. But take your time, and you can get them pretty close. I don't know if you could see those ones without the solder on them. You get it pretty close. And from the top side, it looks just perfect. So that's the way I deal with this, and that relay should make a big difference in how the amplifier performs, because we're not going to have resistance in our contacts anymore. Okay, new relays in. I replaced the capacitors with 105 temperature caps. Again, I didn't test them, but all that heat in there, it's just not something I want to leave, how it is. So let's put this in and let's see if we repaired that problem with the distortion on the speaker. Okay, now some of you might ask about this relay down in here, if it should be checked or replaced or whatever. And typically, no, you don't have to mess with this one. It's a much heavier contacts on the relay. And the cool thing about it is it will never be put into a situation where the contacts will get arced up unless you have a failure of a component. If you recall, on the back of the amplifier, at the very beginning of the video, I showed you a big gray ceramic resistor on the power supply board underneath. And I told you that that resistor is very low resistance, and it is a soft start resistor to pre-charge the capacitors before the amplifier goes into full power. And that prevents that big inrush current when you first turn the unit on. So that kind of saves your power switch, keeps you from blowing the mains breaker in your house. And this is directly across that resistor. So that resistor, even though when those capacitors are charged, that resistor is going to have very, very little voltage drop across it. It's going to be a tiny voltage, maybe a couple of volts. And this is going to close at that point in time. So what you're closing out is a very small voltage and conversely a small current. So this will never really arc or damage the contacts. So they very rarely fail. The only way that this will fail is if that big resistor fails. If the big resistor fails and that were to close, that would cause that to happen. But the way this circuit is designed, the coil of this relay is across the capacitors. And if the capacitors don't pre-charge to a certain level, the coil won't have any energy to pull in, and therefore this will just stay open all the time. So long story short, if that big ceramic resistor opened, this would never come in to damage the contacts in the first place. It's a really cool design. It's very simple, and I kind of showed this on some other devices where I built this same circuit into a large amplifier that did not have inrush current protection. So that's, long story short, why you do not need to worry about this relay. Okay, I'm connected back up. Let's turn it on. Oh, it would help if I plugged the board back in now, wouldn't it? Sometimes the wheel is turning, but the hamster's dead. What can I say? There. All right, let's flip this around and see if we have better luck this time. Okay. Now I should plug it into the wall. Okay. This is good. And our protect relay came in. So let's play some music. Let's see here. Let's take that same song, whatever it is. Totally clean. No distortion. Looks like that fixed it. Happens to our dim bulb. And when it lights up like that, the voltage drops, the transistors go out of balance, and that causes the DC offset to go above, up towards that 1 volt range or so, and that trips the protect circuit. And that's what that does. And also, conversely, if something shorted or failed or we did something wrong, same thing. That bulb would get brighter, the voltage would drop, and it would limit the current into the amplifier. All right. Okay, I'm thinking we got it. Okay, I think I'm going to end this right here for this part. And we're kind of at a good point right now. We're going to need to go through and do the amplifier boards, which are going to be very simple. They're going to be mostly cleaning. I think there's only a couple of electrolytic capacitors on there that we may or may not need to change. And the rest is going to be checking the alignment, which I have no reason to believe that it's not going to be right on. We're probably not going to have to touch anything, especially in the tuner section. And then we'll do our battery of tests. and then this thing will be done. So we'll be able to wrap this up in the next video very easily. But I think I am going to split this into two parts. One long part, which is this one, and then possibly a shorter part to finish it up. So until then, I wish you all peace, joy, happiness, and good health in your lives. And I thank you all for the comments and all the kind words. And I wish you all the best. We'll see you all soon. Take care. Bye-bye.